Okay, good morning. Welcome to
Family Math number 411.
Family Math number 411. So yesterday we saw an amazing, really just awesome public lecture by Tadashi Tokieda over at the MIT Open House. What did you guys like about that lecture? What are some things that you liked?
There's a lot of, he did a lot of stuff with origami, and I like origami.
Okay. What did you like?
He did a lot of interesting tricks that's involving just folding stuff.
Okay. Yeah, it was neat. He was actually a really good speaker. There were lots of like really preeminent mathematicians in the audience, and there were lots of kids in the audience. So it was a fantastic lecture. This is one thing I've seen of his online. He did at a lecture at MoMath that he didn't do yesterday. So I thought I'd start with this just to show you some other things that he's done. So he takes a cup, like a coffee cup here, and he shows that if you ring it, make some noise with it.
Yep.
That it makes a noise.
Yeah.
And it seems to be making the same noise, right?
Mhm. Yeah.
Okay, so it seems to make the same noise when you strike it. And so what are some things you might wonder about that?
Well, is there any different noise?
Is there a different noise?
Does it actually make the same noise?
Does it actually make the same noise? Yeah.
Because if you hit it here, this handle may get in the way.
Oh, yeah. Okay, maybe the handle creates a problem.
When you do it opposite, the handle's not in the way.
Ah, very good. When I hit it over here, it seems to be making the same noise as the handle. And there's no handle over here. That's interesting. And so another question mathematicians wonder about shapes like this is, do the noises they make determine the shape? So like going the other way around, if you heard this noise, would you be able to tell what shape this was?
Well, what if there's a different noise?
Yeah, and that's what he shows. And it might be interesting to see how well the camera listens. But if I hit it over here, is that the same noise?
No.
Higher.
Higher.
So now I found two noises. What was different about the way I was hitting it this time compared to last time?
Well, you were hitting it sort of straight on here,
Uh-huh.
and now you're hitting it with the diagonal.
Okay. So the first time I was hitting it almost like on the X and Y axes
Yeah.
at 90 degrees. But now I've rotated 45 degrees. And I get a higher pitch.
What if you rotate more?
Well, I know if I rotate by 90 degrees, I'm back to where I was before.
Yeah.
Yeah, but like, what if you rotate 60 degrees?
Yeah, what? Do you want to try?
Alright. So this is 45.
Yeah.
Slightly different, I think.
It seems like
It's hard to rotate it, like, it's sort of obvious to rotate at 45 and 90, but
But
it's
then how do you...
harder to know when you're rotating
it seems
60.
like between like these points, like 0, 45, it seems like it just goes, just like slowly gets higher, and then from 45 to 90 it gets, and then 45 to 90 it gets lower again.
Yeah, it probably does.
Yeah,
It probably does.
these are like blends of the two sounds, and then here is the higher sound, here's the lower sound.
Yeah, it's interesting. Do you remember when he was talking about shapes stretching and shrinking?
Yep.
And what happens when you normally you take a shape and you push in at these 90-degree angle, or push in here, what happens?
It expands.
It expands in this direction.
Yeah.
And if I push in this direction, what
It
happens?
expands that way.
Yeah, and so what he was explaining in the MoMath lecture was that it's a little more difficult for this cup to shrink and expand where the handle is. It's because it's a little heavier there.
Yeah.
And then it's a little easier for it to shrink and expand away from the handle. And that's why it's a higher pitch.
What if there was no handle?
Ah, great question. We would need to see if we had something that had no handle. Ah, look at this. I happen to have, even better. Well, actually, this is probably best. That has no handle, so go 90 degrees. And then do over here. And then up here. Sound like those are the same
Yeah.
on our axis here. Now rotate 45.
Seems like it's the same.
Seems like it's the
So
same.
it depends on if you have a handle.
Seems like it. That's pretty neat, right?
Yeah.
Well, that's pretty neat. That's a pretty interesting application of math. All right, so let's go on to one other. We'll do two more things that he did yesterday. Okay.
Okay.